Hello everyone and welcome to this video. In the last video we discussed about classification of organic compounds based on the position of functional group. We said that can be primary, it can be secondary or in tertiary. Now from now on we will talk about some important chemical reactions of some of the series. Okay, let's start our discussion with alkanes. In this video we will talk about alkanes. If you look at alkanes, they are one of the simplest hydrocarbons. They are very simplest hydrocarbons. They are based on only two types of elements, carbon and hydrogen only. And what type of bond is present in them? Only carbon-carbon bond, or it is carbon-hydrogen bond. Only these two type of bonds are present. And this bond energy for carbon-carbon bond is 346 kilojoule per mole, and carbon-hydrogen bond is around 414 kilojoule per mole. These alkanes are normally called inert. Inert means they are not that much reactive, but they do undergo some of the very important chemical reactions. Very important chemical reactions. Let's see some of them. For example, combustion of alkanes. Combustion reaction. Let's talk about combustion of alkanes. Combustion can be classified as burning. We know that alkanes are normally used as fuels because when you burn them, when you combust them, they have they release a very high amount of energy. Okay, there is a thing which is called volatility. When the number of carbons increases, this volatility factor decreases. What is this volatility factor? It's like tendency of a substance to change from liquid to gas. Like for example, if you take a petrol in a bottle and you put it somewhere, and if you open the bottle cap and you come after a few days or few time, you will see the quantity of the petrol will be less. Why? Because some of that petrol became fumes, become gas and goes evaporates. That's why when you go to petrol stations, they're also like smell because it's like continuously converting to vapor form. So this continuation, this conversion of substance from liquid to gas form, it's called volatility factor. When the number of carbon increases, this factor decreases. So we can say that the shorter chain alkanes are better fuels. They are better fuels. Like if you have a alkane with which has 6 carbons and one is 8 carbon, so 6 carbon will be better fuel. 6 carbon will be a better fuel. Okay, now let's see the equation of this combustion reaction. Keep this thing in mind. This combustion is of two types. Not for alkanes, but for any chemical reaction, combustion is the same. Combustion is two types. One is called complete combustion and one combustion is called incomplete combustion. Incomplete. Spelling of complete, I think I'm wrong. Yes, here it's incomplete. Whether it is complete or it is incomplete, combustion always occurs in the presence of oxygen. Always in the presence of oxygen, and it gives you carbon dioxide and water, or it will give you carbon monoxide or water. If it's a complete combustion, you will get carbon dioxide and water. If it's an incomplete combustion, you will get carbon monoxide and water. Let me show you with examples. Let's say we have C8H18, we have octane, and we want to do combustion, so it must be in the presence of oxygen. So we have oxygen. If it is combustion in the presence of oxygen, it will always be, so what will be the product? CO2 plus H2. If you balance it, you want to have here 12.5, this is 8, so you must have a 8 here and here a 9. So this is the balanced equation. This is complete combustion. How I know this is a complete combustion? Because I have a carbon dioxide here. Okay, and if it doesn't in the question it doesn't like say like it's an incomplete combustion, then it always considered as a complete combustion. If it's an incomplete combustion, what's the difference? This complete combustion, you have like excess oxygen. When the supply of oxygen is extra, it is called complete combustion. So this is complete. And if your oxygen is limited, then this chemical reaction is called incomplete combustion. Like for example, you have C5H12. It is also oxygen, but the supply of oxygen is mentioned that it is limited. It's not excess. So what will be the product? Now it will be carbon monoxide and water. It will be the same. Chemical reaction is the same. Only difference is carbon monoxide and water. You can balance it. It can be like 5.5. It can be 5CO, and this is 6H2. If you have any problems in equation balancing, I have some videos on equation balancing. Keep this thing in mind. If you go to an IB exam hall or IEC exam hall or wherever you go, if your equation is not balanced, your answers will never be correct. So you must know how to balance equations. If you don't know how to balance equations, we have some videos. You can go to that section and watch them, because this is very important. You should know how to balance the equations. So this is combustion. It can be complete, it can be incomplete. Here oxygen supply is limited, so we call it incomplete combustion. Whether it is complete or incomplete, it always occurs in the presence of oxygen. That's why you can see, if you're a car lover, you will see that in internal combustion engines of the cars, the oxygen is limited, so the product is carbon monoxide. Then there is a converter in the car which is called catalytic converter. What's the function of this converter? Is that it supplies further oxygen and converts carbon monoxide to carbon dioxide, because this carbon monoxide is very deadly. It's more dangerous gas as compared to carbon dioxide. Moving forward, let's see some more chemical reactions alkane can do. In organic chemistry, you will find mostly three types of chemical reactions. In organic chemistry, you will find these three types of chemical reactions the most, which includes addition. Addition means to add, like I have something, I add something to it, it's called addition. Second is called substitution. Substitution means to replace, like swap, change position, like A replaced with B, B replaced with A. Substitution. And elimination. Elimination means to remove. You will find mostly these three types of chemical reactions in organic chemistry. But if you consider alkanes, in the case of alkanes, alkanes cannot do addition. Why? Because they are already full. If you look at the structure of alkane, let's draw a small one. Let's draw ethane, for example. You see carbon, carbon, here it's hydrogen. They are full. This is full structure. You cannot add anything to it. See, it's already full. So addition is not possible. Yes, substitution is possible. Like you swap this hydrogen with something else, it's called substitution. Elimination is also possible. You like eliminate some of it and add something, it's also possible. So, but addition is not possible. Now we want to talk about a very important chemical reaction which alkanes do. It's called free radical substitution. To start this chemical reaction, first we want to talk about some fission reaction here. Let's say we have a chemical reaction if you have a molecule, covalent molecule A with B. Let's say we have this, like they are sharing one electron. Now what happened? They want to split. They want to break the bond. When they want to break the bond, they have option number one for them is that they just take their electrons and they go away. Like A and B were bonded, they split up. A took its electron, B took its electron. Like in simple words, you and your friend started a company with 50-50 investment. After some time, you say that you cannot have business together, so you split. He takes his share, half of the company, you take half of the company, so you split evenly. This is called even splitting. Even splitting. So this is called homolytic fission. What is homolytic fission? In which bond is broken and they take their electrons, they split evenly. One atom takes his electron, other atom takes his electron, and they split evenly. This is called homolytic fission. There is one more fission which is called heterolytic fission. Let's suppose this is the case. A and B, they made a bond, they have a covalent bond. Now they split up. What happened? B took the electron with it. B took both the electrons. Now when he took both the electrons, it became ion, so it's a positive ion and a negative ion. Like you and your friend make a company. Now after some time you realized you cannot be together, so you had a fight. What do? You said that I'm the one who ran the company, you did not do anything. So he took all the shares and kick you out. So it's like B took the electron and he kick you out. So it became positive ion because it's short of electron. This is a negative ion because it's an extra electron. This type of fission is called heterolytic. Heterolytic fission. Okay. Now why I'm discussing this? Because this is the base for free radical substitution. When you have this when you have this chlorine, in the presence of UV light, it do homolytic fission. Okay, we'll talk about it. So what's the main reaction of free radical substitution? Let's take an alkane. We have, for example, CH4. It reacts with chlorine, and what happens? They swap, like they substitute. One hydrogen takes chlorine's place, and you get what? You get CH3Cl plus HCl. Like, let me show you the structure here. You have carbon, 4 hydrogens, and you have chlorine bonded with chlorine. What happens? This hydrogen and this chlorine changes position. They changes the position, and you get what? You get carbon with chlorine, and here is carbon, here is hydrogen, sorry, this is hydrogen and this is hydrogen, and here you get what? HCl. See this swap, this substitute, that's why this is called substitution, free radical substitution. Behind the steps, what happened overall, what is happening here? There are 3 steps. First step is called initiation. Initiation means the start of the chemical reaction. How do we start this chemical reaction? The first step is that this chlorine, when you have this chlorine in the presence of UV light, okay, what happens? This chlorine do homolytic fission and splits up and become 2 chlorine ions. 1, 2, 3, 4, 5, 6, 7. It was bonded, but what happens when it is UV light? It undergoes homolytic fission. We discussed earlier that they split up for a short period of time. Okay, they split up. Now when they split up, what happens? This chlorine goes to this one, this free radical of chlorine contacts methane. It contacts methane and takes one hydrogen from it because he wants to get stable. When he wants to get stable, he takes one hydrogen from this methane and becomes HCl. They become stable. Chlorine has 8, hydrogen has 2, so they are stable. But this methyl radical becomes unstable now. This is unstable now. This methyl goes to another chlorine and says that, hey, your chlorine took my hydrogen, now I have become unstable, what should I do? So this chlorine gives him one partner, and this becomes CH3Cl, and now this chlorine is now having a free radical now. See what happening? They are substituting. First this chlorine goes to methane, takes one hydrogen, then this methyl goes to chlorine, takes one chlorine. So they are substitution. This step is called propagation. Exchanging ions. This is called propagation. Now when it's the closing time, it's called termination. What happens? Whatever partner they find, they make it the bond and they want to become stable. It's called termination. Like chlorine radical, gets a chlorine radical, bonds together and becomes chlorine. 8, 8. When they have 8, 8, they become stable. Similarly, methyl and chlorine, they combine, methyl radical, and they become what? CH3Cl. Similarly, there is also a possibility that CH3 combines with CH3. Whatever ions they find, they just want to become stable, to terminate it. This step is called termination. So it has 3 steps: initiation, then propagation, and then termination. This is a very important reaction. It's called free radical substitution. Any alkane reacts with halogen in this format, they cannot do addition, they can do free radical substitution. In the next video, we will see some important reactions of alkenes. That is all we wanted to discuss from the alkane reactions. Thank you so much for your time. See you next time around.